Right now, as you read these words, your body contains atoms that are 13.8 billion years old. Not millions, not billions, 13.8 billion years. Every single atom in your left hand is older than the Earth itself. In fact, your left hand and your right hand might contain atoms that were born in completely different stars, separated by thousands of light years, now reunited in you. You are not just made of stardust, as the poets say. You are a walking museum of cosmic history, a temporary assembly of matter that has witnessed the entire story of the universe. But here's what makes this truly extraordinary. The hydrogen atoms in your body, the ones forming the water in your cells, the ones helping your DNA hold its shape, those atoms haven't changed since the first 3 minutes after the Big Bang. They are pristine relics from the moment when the universe was a seething ocean of pure energy, cooling just enough for the first matter to condense. The carbon in your muscles, the oxygen you're breathing right now, the calcium in your bones. These came from inside dying stars that exploded billions of years before our sun even existed. And the iron in your blood, the very substance that carries oxygen to every cell in your body, that iron was forged in the most violent event in the cosmos. A supernova explosion so powerful, it briefly outshone an entire galaxy. You are, quite literally, made of dead stars. But not just one star, dozens of them, perhaps hundreds. Let me show you something that will change how you see your own hand forever. Hold it up. Look at it. That hand contains approximately 7 octillion atoms. That's 7 followed by 27 zeros. Now here's the staggering part. Those atoms didn't all come from the same place. Some were born in the Big Bang. Others were cooked in the cores of red giants over billions of years. Still others were created in the final catastrophic seconds of a supernova. Your body is a mosaic of cosmic events, each atom carrying its own ancient history. In 1957, a physicist named Fred Hoyle stood before a blackboard at Cambridge University and solved one of the greatest mysteries in science. For decades, scientists had known that stars produced energy through nuclear fusion, but they couldn't explain where all the elements in the universe came from. Hydrogen and helium, yes, those came from the Big Bang. But what about carbon, oxygen, iron, gold? Hoyle, working with colleagues Margaret Burbidge, Geoffrey Burbidge, and William Fowler, published a paper that would revolutionize our understanding of existence itself. They showed that every element heavier than helium was forged inside stars. They called it stellar nucleosynthesis. We call it the reason you exist. But to truly understand what you're made of, we need to go back. Not to your birth, not to your parents' birth, not even to the formation of Earth 4.5 billion years ago. We need to go back to the very beginning. Imagine compressing the entire history of the universe into a single day, 24 hours. At midnight, the Big Bang occurs. For the first 3 minutes, just the first 3 minutes of this cosmic day, the universe is so hot and dense that it's essentially a soup of pure energy and the simplest particles. Protons, neutrons, electrons. As the universe expands and cools, these particles begin to stick together. Protons capture neutrons. The first atomic nuclei form. Hydrogen, helium, tiny traces of lithium. That's it. For the first 3 minutes of cosmic history, the universe creates only the 3 lightest elements. Now, in our 24-hour timeline, those first 3 minutes happen in the first fraction of a second after midnight. By 12:01 a.m., the basic building blocks of matter are set. But here's the crucial point. No carbon yet. No oxygen. No nitrogen. None of the elements that make life possible. The universe at this moment is chemically boring. Just hydrogen and helium drifting in the darkness. For hours in our compressed timeline, representing hundreds of millions of real years, nothing much happens. The universe expands. It cools. Hydrogen and helium gas spread out into vast clouds. And then, around 2 a.m. in our cosmic day, something extraordinary occurs. gravity begins to win. The gas clouds start to collapse. They grow denser, hotter, and approximately 300 million years after the Big Bang, the first stars ignite. These weren't stars like our Sun. They were monsters. Some contained not 10 times the mass of our Sun, not 100 times, but up to 300 times more mass. Astronomers call them population 3 stars, and not a single one exists anymore. They all died billions of years ago. But while they lived, they did something remarkable. They became the universe's first chemistry labs. Inside the core of a star, the temperature reaches 15 million degrees Celsius. At these temperatures, hydrogen nuclei, just single protons, move so fast that when they collide, they overcome their natural repulsion and fuse together. 2 hydrogen nuclei become 1 helium nucleus. This process releases tremendous energy. It's what makes stars shine. But it also does something else. It creates new elements. Here's where it gets beautiful. When 4 hydrogen nuclei fuse into 1 helium nucleus, the helium weighs slightly less than the 4 hydrogens did. That missing mass doesn't disappear. It converts into energy, according to Einstein's famous equation. The star shines, but the helium nucleus remains. And as the star ages, as it burns through its hydrogen fuel, the core grows hotter. Hot enough for helium nuclei to fuse. 3 helium nuclei combine to form carbon, the first carbon in the universe. The element that will one day form the backbone of every organic molecule, every protein, every strand of DNA. This is where Fred Hoyle's insight becomes crucial. He realized that the formation of carbon inside stars required an almost miraculous coincidence. The energy levels had to align perfectly, or carbon would never form in sufficient quantities. He called it the _0_. 3 helium nuclei, each called an alpha particle, combining in a precise dance. The probability seemed impossibly low, yet it happens. It must happen because we exist, and we are made of carbon. But stars don't stop at carbon. As they age, as their cores grow even hotter, they continue fusing elements. Carbon fuses into oxygen, oxygen into neon, neon into magnesium, magnesium into silicon. Each fusion requires higher temperatures. Each step releases less energy. The star is climbing an energetic hill, and at the top of that hill sits iron. Iron is special. It's the most stable nucleus in the universe. Fusing iron doesn't release energy, it consumes energy. So when a massive star's core fills with iron, fusion stops. The core can no longer support itself against gravity, and in less than a second, the core collapses. What happens next is almost beyond comprehension. The core of the star, an object roughly the size of Earth but containing more mass than our Sun, collapses to a sphere just 20 kilometers across. The density becomes so extreme that protons and electrons are crushed together, forming neutrons. The collapse happens so fast that the outer layers of the star don't have time to react. They're still falling inward when the core rebounds. The shock wave from this rebound travels outward at a significant fraction of the speed of light. When it reaches the surface, the star explodes, a supernova. For a few weeks, that single exploding star shines as brightly as an entire galaxy of 100 billion stars. The explosion is so violent, so energetic, that it creates conditions that don't exist anywhere else in the universe. In the heart of the explosion, elements heavier than iron form for the first time. Gold, platinum, uranium. Every atom of gold in every ring, every necklace, every circuit board on Earth was created in the final seconds of a dying star's life. But here's what matters for your story. When that star explodes, it doesn't just create heavy elements, it scatters them. All the carbon that was slowly built up over millions of years, all the oxygen, all the silicon and sulfur and calcium, it all gets blown into space at thousands of kilometers per second. The explosion seeds the galaxy with the raw materials for new stars, new planets, and eventually, new life. Now imagine this happening not once, but billions of times. Throughout the history of the Milky Way galaxy, stars have been born, lived, died, and exploded. Each generation of stars inherits the elements created by previous generations. Each supernova enriches the interstellar medium with heavier elements. Astronomers call this process quote one, and it's the reason you exist. Our Sun is a third-generation star. It formed 4.6 billion years ago from a cloud of gas and dust that had already been enriched by at least two previous generations of stars. That cloud contained hydrogen and helium from the Big Bang, yes, but it also contained carbon from red giants, oxygen from massive stars, and iron from supernovae. When the cloud collapsed to form our Sun, not all the material fell into the star. Some of it remained in orbit, forming a disk. And from that disk, the planets condensed. Earth formed from the debris of dead stars. Every mountain, every ocean, every grain of sand, it's all recycled stardust. But Earth didn't form with life. For the first few 100 million years, our planet was a hellish place. Volcanoes covered the surface. The atmosphere was toxic. Asteroids and comets bombarded the surface constantly. The young Earth was being sterilized by impacts, over and over again. But those impacts brought something crucial: water, organic molecules. The comets that crashed into Earth carried the building blocks of life, and those building blocks were made of elements forged in stars: carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. The 6 elements that make up 99% of all living matter. All of them, except hydrogen, were created inside stars. Somewhere around 3.8 billion years ago, something extraordinary happened in Earth's oceans. Molecules began to organize themselves. Simple organic compounds formed more complex structures. RNA, or something like it, appeared. A molecule that could store information and catalyze chemical reactions. The first self-replicating systems emerged. Life began. But here's the profound truth. Life didn't create new atoms. It couldn't. The atoms were already there, floating in the ocean, remnants of exploded stars. Life simply organized them in new ways. It took carbon atoms that had been forged in a red giant 5 billion years ago and arranged them into amino acids. It took oxygen atoms from a supernova and incorporated them into water molecules. It took iron atoms, created in the most violent explosion imaginable, and placed them at the center of hemoglobin molecules. Every living thing on Earth is made from the same cosmic inventory. The carbon in a tree, the calcium in a seashell, the iron in your blood, it all came from stars. But here's what makes it even more remarkable. Those atoms have been recycled countless times. The oxygen atom you just breathed in might have been part of a dinosaur 65 million years ago. Before that, it might have been in the ocean. Before that, in a volcano. Before that, in a different ocean on a different continent. And before Earth even existed, it was inside a star, waiting to be released. You are not a fixed thing. You are a process. A temporary pattern imposed on matter that is constantly flowing through you. The atoms in your body right now will not be the same atoms in your body 7 years from now. You replace your entire atomic structure on a regular cycle. You eat food, plants and animals that are themselves made of recycled star matter. You breathe air, oxygen created in stars billions of years ago. You drink water, hydrogen from the Big Bang, oxygen from a supernova. These atoms become part of you for a while, and then they leave. They return to the environment. They become part of other organisms. The cycle continues. But while those atoms are part of you, they do something extraordinary. They think. They feel. They wonder about their own origins. Atoms that were created in the mindless furnace of a star have organized themselves into a structure complex enough to contemplate the universe that created them. You are the universe becoming aware of itself. Let me give you a specific example: the iron in your blood. Right now, as you read this, your heart is pumping blood through your body. That blood is red because of hemoglobin, a protein that contains iron at its core. Each hemoglobin molecule has 4 iron atoms. Each iron atom can bind 1 oxygen molecule. This is how your body transports oxygen from your lungs to your cells. Without iron, you would suffocate, even in a room full of air. But where did that iron come from? Not from the Big Bang. The Big Bang was far too cool to create iron. Not from normal stellar fusion. That only goes up to iron, and even then, only in the most massive stars. No, the iron in your blood was created in a supernova. Specifically, it was created in the fraction of a second when a massive star's core collapsed and rebounded. In that moment, the temperature and pressure became so extreme that silicon nuclei were crushed together, forming iron. The explosion scattered that iron into space. Billions of years later, some of it ended up in the cloud that formed our solar system. Some of that ended up in Earth. Some of that ended up in the food chain, and some of that ended up in you. Every time your heart beats, you are using atoms that were forged in one of the most violent events in the universe. The iron atom, carrying oxygen to your brain right now, has a history spanning billions of years and thousands of light years. It has traveled across the galaxy. It has been part of interstellar clouds, asteroids, oceans, plants, animals, and now you. And when you die, that iron atom will continue its journey. It will return to the Earth, be taken up by other organisms, and continue the cycle. This is true for every atom in your body. The calcium in your bones was created in a massive star and ejected in a supernova. The phosphorus in your DNA was created in the same way. The sodium and potassium that allow your neurons to fire, transmitting thoughts and memories, they too were forged in stars. You are not just connected to the cosmos, you are made of it. You are a collection of atoms that have been on a journey lasting 13.8 billion years, and that journey has led them, temporarily, to you. Now, here's where it gets even stranger. Not all the atoms in your body came from the same star. In fact, they almost certainly didn't. The Milky Way galaxy has been forming stars for over 13 billion years. During that time, hundreds of billions of stars have lived and died. Each supernova scattered its elements across a region of space hundreds of light years across. Those elements mixed with gas from other supernovae, from other stars. By the time our solar system formed, the cloud of gas and dust that became the sun and planets was a mixture of material from countless different stars. This means that the atoms in your left hand might have come from a star that exploded on one side of the galaxy, while the atoms in your right hand came from a star on the opposite side. The carbon in your skin might have been created in a red giant that died 8 billion years ago, while the carbon in your bones might have come from a different star that died 6 billion years ago. You are a mosaic, not just of different elements, but of different stellar histories. In 2006, a team of astronomers led by Anna Frebel at the University of Texas discovered one of the oldest stars in the Milky Way. They called it HE 1523-0901, a designation that hardly captures its significance. This star formed less than 200 million years after the Big Bang, making it over 13 billion years old. When they analyzed its spectrum, they found something remarkable. It contained almost no elements heavier than helium, just tiny traces of carbon, oxygen, and iron. This star formed from gas that had been enriched by only 1 or 2 previous supernovae. It's a relic from the early universe, a window into a time when the galaxy was chemically young. Compare that to our sun. When astronomers analyze the sun's spectrum, they find dozens of elements in significant quantities: carbon, nitrogen, oxygen, silicon, iron, magnesium, sulfur. The sun is metal-rich in astronomical terms. It formed from gas that had been enriched by billions of years of stellar evolution. And that's why planets like Earth could form around it. That's why life could emerge. The early universe didn't have enough heavy elements to build rocky planets. It didn't have enough carbon and oxygen to build organic molecules. Life had to wait for stars to live and die, enriching the cosmos with the elements necessary for complexity. You are a product of that enrichment. Every atom in your body heavier than helium is proof that stars lived and died before you were born. You are the beneficiary of billions of years of cosmic alchemy. But let's bring this back to something tangible, something you can feel right now. Take a deep breath. Hold it. The oxygen you just inhaled, roughly 21% of the air you breathed, was created inside a massive star. That star lived for perhaps 10 million years, fusing hydrogen into helium, helium into carbon, carbon into oxygen. When it exhausted its fuel, it exploded, scattering that oxygen into space. Some of it eventually made its way to Earth. Plants took that oxygen and released it through photosynthesis. You breathed it in. And now, in your lungs, that oxygen is binding to the iron in your hemoglobin. Iron that was created in a different supernova, possibly in a different part of the galaxy, possibly billions of years apart. Two atoms, created in separate cosmic catastrophes, separated by unimaginable distances and timescales, have come together in your body to keep you alive. This is happening right now. This is happening with every breath you take. The hydrogen in your body has an even more ancient story. Unlike the heavier elements, hydrogen wasn't created in stars. It's primordial. The hydrogen atoms in the water molecules in your cells, in the organic molecules that make up your proteins and DNA, those atoms formed in the first 3 minutes after the Big Bang. They are 13.8 billion years old. They have existed since the universe was a tiny fraction of its current size, since the temperature was billions of degrees, since there were no stars, no galaxies, no planets, no life. Those hydrogen atoms have been on an extraordinary journey. For hundreds of millions of years, they drifted through the expanding universe as part of vast clouds of gas. Then, gravity pulled them together. They became part of the first stars. Some of those stars exploded, scattering the hydrogen back into space. The hydrogen drifted again. It became part of new clouds. New stars formed. Some of those stars had planets. On at least one of those planets, the hydrogen became part of water molecules. Those water molecules rained down on the surface. They filled the oceans, and in those oceans, life began. The hydrogen in your body has been part of countless organisms before you. It's been in bacteria, in algae, in fish, in dinosaurs, in mammals. It's been in the ocean, in clouds, in rain, in rivers, in ice. It's been in plants and animals that lived and died millions of years before humans existed. And now, it's in you. When you die, it will continue its journey. It will return to the environment. It will become part of other organisms. And billions of years from now, long after the sun has died, long after Earth has been destroyed, those hydrogen atoms will still exist, ready to become part of whatever comes next. This is the true meaning of Quote 2. It's not a poetic metaphor. It's a literal scientific fact. Every atom in your body has a cosmic origin story. Every element has traveled across space and time to become part of you. You are not separate from the universe. You are a temporary expression of it. Now let's trace the journey of a single carbon atom. Not metaphorically, not abstractly. Let's follow one specific carbon atom from its birth to this present moment, where it sits in a molecule of glucose in your bloodstream, about to be broken down to power your thoughts as you process these words. Our story begins 6 billion years ago, halfway across the Milky Way galaxy from where Earth orbits today. A massive star, let's call it Star A, has been burning for 4 million years. It started with 50 times the mass of our Sun, a blue supergiant so luminous it could be seen from thousands of light years away. For millions of years, this star has been fusing hydrogen into helium in its core. But now, the hydrogen is running out. The core contracts. The temperature rises. And at 100 million degrees Celsius, a new reaction begins. Helium fusion. Three helium nuclei collide in rapid succession, the triple alpha process that Fred Hoyle predicted. In that moment, our carbon atom is born. It's carbon-12, the most common isotope, with 6 protons and 6 neutrons in its nucleus. This atom didn't exist a microsecond ago. Now it does. It will exist, unchanged, for the rest of time. But our carbon atom doesn't stay in the core for long. As star A continues to age, it develops a layered structure like an onion. Hydrogen fusion in the outer shell, helium fusion in the next layer down, and in the core, carbon begins to fuse into heavier elements. Oxygen, neon, magnesium. The star swells to enormous size, becoming a red supergiant. Its outer layers expand past where Mercury would orbit if this were our solar system. And in those outer layers, carried by convection currents in the star's plasma, our carbon atom rises to the surface. For 100,000 years, our carbon atom circulates through the outer envelope of star A. The star is now so large that light takes hours to travel from its core to its surface. The temperature at the surface is relatively cool, only 3,000 degrees. The star glows deep red. And then, after 4.2 million years of life, star A runs out of fuel. The core, now composed of iron, can no longer support fusion. In less than 1 second, it collapses. The rebound sends a shockwave through the star. Star A explodes. Our carbon atom, sitting in the outer layers, is suddenly accelerated to 5,000 kilometers per second. That's more than 1% of the speed of light. The explosion is so violent that it tears the star apart completely. No remnant remains. No neutron star, no black hole. The entire mass of star A, except for what collapsed into the core, is scattered into space. Our carbon atom is now part of an expanding shell of gas, glowing hot from the energy of the explosion, racing away from the site of its birth star. For the next 200 million years, our carbon atom travels through interstellar space. It's part of a vast cloud of debris, mixing with the ambient gas of the galaxy. The cloud expands. It cools. The carbon atom, once part of a star burning at millions of degrees, now drifts in space at a temperature just a few degrees above absolute zero. It's surrounded by other atoms, oxygen from the same supernova, iron from the core collapse, hydrogen that's been floating in space since the Big Bang. The cloud is dark, silent, seemingly lifeless. But gravity is patient. Slowly, over millions of years, the cloud begins to collapse. Not uniformly, it fragments into smaller clouds, each collapsing under its own gravity. Our carbon atom becomes part of one of these fragments. The fragment contracts. As it does, it begins to spin faster, like a figure skater pulling in their arms. A disk forms. And at the center of the disk, the temperature and pressure rise. 5.8 billion years ago, a new star ignites. Let's call it star B. Our carbon atom doesn't fall into star B. It remains in the disk, orbiting the young star. The disk is a chaotic place. Dust grains collide and stick together. Pebbles form, boulders, planetesimals. Our carbon atom, bonded now to 2 oxygen atoms as carbon dioxide, becomes part of a growing body. Over millions of years, this body sweeps up more and more material. It grows to the size of Mars, then larger. Gravity pulls it into a sphere. A planet is forming. But this planet is not Earth. It's in the wrong orbit, too close to star B, where temperatures are too high for water to condense. Our carbon atom spends the next 100 million years as part of this hot, rocky world. The planet has no atmosphere to speak of, no oceans, no life. It's a dead ball of rock, orbiting a star that will never know the touch of living things. And then, catastrophe. Another planetary embryo, nearly as large, has been following a chaotic orbit. The two bodies collide. The impact is so violent that both planets are partially vaporized. Our carbon atom is thrown back into space, part of a debris cloud orbiting star B. Some of this debris will eventually coalesce into a new planet. Some will fall into the star, and some, including our carbon atom, will be ejected from the system entirely. For the next 3 billion years, our carbon atom wanders the galaxy. It's no longer part of any star system. It's a rogue atom, drifting through the interstellar medium. It travels 20,000 light-years, crossing spiral arms, passing through regions of active star formation and regions of empty space. It witnesses the birth and death of thousands of stars, though witness is perhaps the wrong word for an unconscious atom. It simply exists, unchanged, patient, waiting. 4.6 billion years ago, our carbon atom's journey takes a new turn. It enters a region of space where a giant molecular cloud is beginning to collapse. This cloud is enormous, thousands of times the mass of our Sun, spanning hundreds of light-years. It's been enriched by multiple generations of supernovae. It contains all the elements necessary to build rocky planets and eventually, life. Our carbon atom is swept up in the collapse. This time, the fragment that contains our carbon atom is in the right place. As the new star, our Sun, ignites at the center, our carbon atom remains in the protoplanetary disk. It's farther from the star than before, in a region where water can condense into ice. The temperature here is cold enough for volatile compounds to freeze. Our carbon atom, still bonded to oxygen as carbon dioxide, becomes part of an icy grain. The grain collides with other grains. They stick together. Over thousands of years, the icy body grows. It becomes a comet, a dirty snowball kilometers across, orbiting in the outer reaches of the young solar system. For tens of millions of years, our carbon atom remains frozen in this comet, far from the warmth of the Sun. But the early solar system is a violent place. The giant planets, Jupiter, Saturn, Uranus, Neptune, are still migrating, their gravity stirring up the orbits of smaller bodies. Around 4 billion years ago, this migration triggers what astronomers call the Late Heavy Bombardment. Countless comets and asteroids are flung into the inner solar system. Some crash into the Sun. Some are ejected into interstellar space. And some hit the inner planets. Our carbon atom's comet is one of them. It falls toward the third planet from the Sun, Earth. The comet enters Earth's atmosphere at 40 kilometers per second. The friction generates tremendous heat. The ice vaporizes. The comet breaks apart. And our carbon atom, liberated from its icy prison, falls as part of a rain of organic molecules into Earth's primordial ocean. The ocean is warm. Volcanic vents on the seafloor pump minerals and heat into the water. Lightning strikes the atmosphere, creating complex organic molecules from simple gases. And in this rich chemical soup, something extraordinary is about to happen. But our carbon atom doesn't participate in the origin of life. Not yet. For the next billion years, it cycles through the ocean and atmosphere. It becomes part of carbon dioxide in the air. It dissolves in seawater. It precipitates as calcium carbonate, forming limestone on the ocean floor. Tectonic activity subducts that limestone into Earth's mantle. Volcanoes erupt, releasing the carbon back into the atmosphere as carbon dioxide. The cycle repeats. 2.5 billion years ago, our carbon atom finally enters the realm of life. Cyanobacteria, the first organisms to perform oxygenic photosynthesis, are transforming Earth's atmosphere. One of these bacteria absorbs our carbon atom as carbon dioxide. Inside the cell, the carbon atom is incorporated into a sugar molecule through the Calvin cycle. For the first time in its 6 billion-year history, our carbon atom is part of a living thing. But the bacterium's life is short. It's consumed by another microorganism. Our carbon atom is broken down, released as carbon dioxide, absorbed by another photosynthetic organism. For the next 2.5 billion years, our carbon atom cycles through the biosphere. It's part of algae in ancient seas. It's part of the first plants that colonize land. It's part of ferns in carboniferous forests. It's part of a dinosaur that lived 100 million years ago. Specifically, part of a protein in the creature's muscle tissue. When that dinosaur dies, our carbon atom returns to the soil. Bacteria break down the tissue. The carbon is released. It becomes part of the atmosphere again. It's absorbed by a flowering plant. The plant is eaten by a small mammal. The mammal dies. The carbon returns to the soil. The cycle continues, over and over, through millions of years and countless organisms. 50,000 years ago, our carbon atom is part of a tree in what will one day be called Europe. The tree lives for 300 years, and our carbon atom spends that entire time as part of the cellulose in the tree's trunk. When the tree dies and falls, fungi begin to decompose it. Our carbon atom is released into the soil. It's absorbed by grass. The grass is eaten by an auroch, a species of wild cattle that will go extinct in the 17th century. Our carbon atom becomes part of the auroch's muscle tissue. A human hunter kills the auroch. The tribe eats the meat. Our carbon atom enters a human body for the first time. It's broken down in the digestive system, absorbed into the bloodstream, and incorporated into the muscle tissue of a Paleolithic human. When that human dies, the carbon returns to the environment. It cycles through more organisms, more plants, more animals, more humans. And then, just a few months ago, our carbon atom was part of a wheat plant growing in a field in Kansas. The wheat was harvested. The grain was milled into flour. The flour was baked into bread. You ate that bread for breakfast. The carbon atom was absorbed in your small intestine, entered your bloodstream as glucose, and right now, right this very moment, it's circulating through your body, waiting to be metabolized to produce the energy that powers your neurons as you contemplate its 6 billion-year journey. This is not a metaphor. This is not a thought experiment. This is the actual history of atoms in your body. Every carbon atom has a story like this. Every oxygen atom. Every nitrogen, calcium, phosphorus, and iron atom. They've all traveled across space and time. They've all been part of stars, planets, oceans, and countless living things. You are a temporary meeting place for matter that has been on an epic journey. But here's what makes this even more profound. The atoms in your body don't just have a past, they have a future. Right now, you're exhaling carbon dioxide. Those carbon atoms are leaving your body. They'll be absorbed by plants. They'll become part of the ocean. They'll cycle through the biosphere for millions of years after you're gone. The calcium in your bones will return to the earth. It might become part of a mountain range. It might be subducted into the mantle and re-emerge in a volcanic eruption 100 million years from now. The iron in your blood will oxidize, rust, become part of the soil. It will be taken up by plants, eaten by animals, incorporated into new life. In a very real sense, you are immortal. Not your consciousness, not your memories or personality, but the matter that makes you up. That's eternal. It cannot be created or destroyed, only transformed. The atoms that are currently arranged in the pattern called you will exist for the rest of time. They'll be part of other organisms, other planets, perhaps even other stars. Billions of years from now, when the sun expands into a red giant and engulfs Earth, the atoms in your body will be vaporized and scattered back into space. They'll become part of new clouds of gas and dust. New stars will form, new planets, perhaps new life. The universe is not a collection of separate things. It's a continuous process of transformation. Matter flows from stars to planets to life and back again. You are not separate from this process. You are an integral part of it. You are the universe experiencing itself, matter temporarily organized in a way that allows it to contemplate its own existence. Let's zoom out for a moment and consider the sheer improbability of your existence. Not just the biological improbability, the fact that your specific combination of genes required a precise sequence of events going back thousands of generations, but the cosmic improbability. The fact that you exist at all required a very specific sequence of events spanning billions of years. If the Big Bang had been slightly different, if the initial density fluctuations had been a bit larger or smaller, galaxies might never have formed. No galaxies means no stars. No stars means no heavy elements. No heavy elements means no rocky planets, no organic chemistry, no life. You wouldn't exist. If the first generation of stars had been different, if they'd been smaller, or if they'd exploded differently, the universe might not have been enriched with the right mix of elements. Too much iron, not enough carbon, and organic chemistry becomes impossible. You wouldn't exist. If our solar system had formed in a different part of the galaxy, too close to the galactic center, where radiation is intense, or too far out, where heavy elements are scarce, Earth might never have developed the conditions necessary for life. You wouldn't exist. If Earth had formed slightly closer to the Sun, it would be too hot for liquid water. Slightly farther, and it would be too cold. If Earth were smaller, it couldn't hold an atmosphere. If it were larger, the atmosphere would be too thick, creating a runaway greenhouse effect like Venus. If the Moon didn't exist, and the Moon formed from a giant impact that could easily have destroyed Earth instead, our planet's axis would wobble chaotically, making climate stability impossible. You wouldn't exist. If the late heavy bombardment had been more intense, it might have sterilized Earth completely. If it had been less intense, Earth might not have received enough water and organic molecules to kickstart life. If photosynthesis had never evolved, the atmosphere would still be anoxic, and complex life would be impossible. If the Cambrian explosion hadn't occurred, animals might never have diversified. If the asteroid that killed the dinosaurs had missed Earth, mammals might never have become dominant, and humans would never have evolved. You wouldn't exist. Every step in this chain had to happen in a very specific way, and yet, here you are, reading these words, breathing oxygen created in stars, thinking thoughts powered by glucose molecules made of carbon atoms that were forged in stellar furnaces billions of years ago. You are the product of an unbroken chain of events stretching back to the beginning of time. But let's make this even more specific. Let's talk about the atoms in your brain. Right now, as you process these words, neurons in your cerebral cortex are firing. Each neuron is a cell containing trillions of atoms. Those atoms are arranged in extraordinarily complex structures: proteins, lipids, nucleic acids, carbohydrates. And those structures are performing computations. They're processing information. They're creating the subjective experience of consciousness. The carbon atoms in the neurotransmitters crossing your synapses right now, those atoms were created in stars. The nitrogen in your DNA, encoding the instructions for building your brain, created in stars. The phosphorus in the ATP molecules powering your neurons, created in stars. The calcium ions flowing through channels in your neuronal membranes, triggering action potentials, created in stars. Your thoughts are literally made of stardust. But it's more than that. The specific arrangement of those atoms, the precise structure of your brain, is the result of billions of years of evolution. Your ancestors were fish. Before that, worms. Before that, single-celled organisms. Before that, self-replicating molecules in a primordial ocean. And before that, simple organic compounds formed from atoms created in stellar explosions. Every step in this evolutionary chain was necessary to produce the brain that's reading these words right now. You are not just made of atoms with cosmic origins. You are the universe's way of understanding itself. For 13.8 billion years, matter has been evolving, increasing in complexity. From quarks to protons, to atoms, to molecules, to cells, to organisms, to brains capable of contemplating their own existence. You are the current endpoint of that process. You are matter that has become conscious. And here's the truly staggering part. You're not unique in this. Every human being is made of the same cosmic material. Every animal, every plant, every bacterium. All life on Earth is built from the same stellar inventory. We are all made of atoms forged in the hearts of dying stars. We are all temporary patterns in the flow of matter through the universe. We are all the universe experiencing itself. But Earth is not the only place where this might be happening. The Milky Way galaxy contains between 200 and 400 billion stars. Current estimates suggest that most of those stars have planets. That means there could be trillions of planets in our galaxy alone. and the observable universe contains at least 2 trillion galaxies. The number of planets in the universe is beyond comprehension. How many of those planets have the right conditions for life? We don't know. But we do know that the elements necessary for life, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, are common throughout the universe. They're created in stars everywhere. Every galaxy has supernovae. Every galaxy is enriched with heavy elements. The raw materials for life are ubiquitous. This means that the process that created you, stellar nucleosynthesis, planet formation, chemical evolution, biological evolution, might be happening on countless worlds throughout the universe. Right now, at this very moment, there might be other beings on other planets, made of atoms from other stars, contemplating their own cosmic origins. They would be asking the same questions you're asking. Where did we come from? What are we made of? What does it mean to exist? And the answer would be the same. They are made of stardust. They are the universe experiencing itself. They are temporary patterns in the eternal flow of matter and energy, just like you. But let's return to Earth, to your body, to this present moment. You now know that every atom in your body has a history spanning billions of years. You know that those atoms were created in stars, scattered by supernovae, incorporated into planets, cycled through countless organisms, and finally assembled into the pattern called you. But what does this mean? How should this knowledge change the way you see yourself and the world? First, it means you are not separate from nature. You are not an observer standing outside the universe looking in. You are part of the universe. You are made of the same stuff as stars, planets, and galaxies. The atoms in your hand are the same type of atoms in distant nebulae. The forces governing the chemistry in your cells are the same forces governing the fusion in stellar cores. You are not separate. You are continuous with everything. Second, it means you are ancient. Your consciousness might be a few decades old. Your body might replace its atoms every few years. But the matter you're made of is 13.8 billion years old. You are older than Earth, older than the Sun, almost as old as the universe itself. You carry within you the entire history of the cosmos. Third, it means you are connected to every living thing. The carbon in your body has been part of countless organisms before you. It's been in bacteria, plants, animals, and other humans. The oxygen you breathe was exhaled by plants. The water you drink has been through the water cycle millions of times. You are not an isolated individual. You are a node in a vast network of matter and energy flowing through the biosphere. Fourth, it means you are temporary. The specific arrangement of atoms that makes you will not last forever. In 100 years, those atoms will be part of other things, other organisms, other processes. The pattern called you will dissolve back into the universe. But the atoms themselves will continue. They are eternal. You are a brief eddy in the river of matter flowing through time. And finally, it means you are extraordinary. Against all odds, against the vast improbability of existence, you are here. You are a conscious being made of atoms that were forged in the hearts of dying stars. You are the universe's way of knowing itself. You are matter that has become aware. And for this brief moment in cosmic history, you have the privilege of contemplating your own origins, of understanding the deep connections between yourself and the cosmos, of experiencing the wonder of existence. Right now, as you finish reading these words, take a moment to feel your body. Feel your heartbeat. Feel your breath. Feel the weight of your body against the chair or floor. Every sensation you're experiencing is the result of atoms interacting. Atoms that have traveled across billions of years and light years to be here, now, as part of you. You are not just in the universe. You are the universe. You are stardust that has learned to think, to feel, to wonder. And that is perhaps the most profound truth of all. Let's talk about something that will fundamentally alter your perception of reality. You've learned that your atoms are ancient, that they came from stars, that they've cycled through countless organisms. But there's a deeper layer to this story, one that reveals just how strange and interconnected the universe truly is. Because it's not just that your atoms are old, it's that they remember. Not in the way you remember your childhood or what you ate for breakfast. Atoms don't have consciousness, but they carry information. Every atom in your body bears the signature of its history. Isotopic ratios that reveal which type of star created it, which nuclear reactions it underwent, how long it spent in different environments. Your body is not just made of stardust, it's made of evidence. You are a walking archive of cosmic history, and scientists can read that archive. Consider the oxygen in your body. Oxygen has 3 stable isotopes: oxygen-16, oxygen-17, and oxygen-18. They're all oxygen, 8 protons in the nucleus, but they have different numbers of neutrons. Oxygen-16 has 8 neutrons, oxygen-17 has 9, oxygen-18 has 10. These isotopes are created in different stellar environments and through different nuclear processes. The ratio between them tells a story. When scientists analyze the isotopic composition of oxygen in your body, they can determine that most of it came from massive stars that exploded as supernovae. But not all of it. Some came from smaller stars that shed their outer layers more gently, forming planetary nebulae. The specific ratios reveal the mix of stellar sources. Your body contains oxygen from dozens, perhaps hundreds of different stars. Each isotope is a fingerprint, a signature of a specific stellar event that occurred billions of years ago. The same is true for carbon. Carbon has 2 stable isotopes, carbon-12 and carbon-13. The ratio between them varies depending on where the carbon was created. Carbon from red giant stars has a different isotopic signature than carbon from supernovae. When you eat food, when you breathe, when you drink water, you're incorporating carbon with a specific isotopic mix. That mix tells the story of stellar nucleosynthesis in our corner of the galaxy. But here's where it gets truly remarkable. Scientists can use these isotopic signatures to trace not just the stellar origins of elements, but their journey through Earth's biosphere. Plants preferentially absorb carbon-12 over carbon-13 during photosynthesis. This means that organic matter, food, wood, fossil fuels, has a slightly different carbon isotope ratio than atmospheric carbon dioxide. By measuring the carbon isotopes in your body, scientists can determine what you've been eating. They can tell if your diet is based on plants that use C3 photosynthesis, like wheat and rice, or C4 photosynthesis, like corn and sugarcane. They can tell if you eat a lot of seafood, which has a different isotopic signature than terrestrial food. Your body is a record not just of cosmic history, but of your own personal history. The atoms in your tissues carry information about where you've lived, what you've eaten, even what you've breathed. You are a living document, written in the language of isotopes. But let's go deeper. Let's talk about the quantum nature of atoms and what that means for your connection to the universe. Every atom in your body is a quantum object. It exists in a state described by probability waves, not definite positions. The electrons orbiting the nucleus don't follow fixed paths like planets around a sun. They exist in clouds of probability, simultaneously everywhere and nowhere until observed. This quantum nature has profound implications. It means that at the most fundamental level, you are not made of solid, discrete particles. You are made of fields of probability, of waves of potential existence. The boundary between quote 8 and quote 9 is not as clear as it seems. Your atoms are constantly exchanging photons with the environment. The electromagnetic fields generated by the electrons in your body extend outward, interacting with the fields of other atoms. You are not a separate object. You are a pattern of quantum fields interacting with other patterns. And here's something even stranger. Because of quantum mechanics, there's a non-zero probability that atoms in your body could quantum tunnel through barriers, could spontaneously appear in different locations, could even swap places with atoms in the environment. This doesn't happen often. The probabilities are vanishingly small for objects as large as atoms in biological systems. But it does happen. At the quantum level, the distinction between your atoms and environmental atoms is fuzzy. You are constantly exchanging matter with the world around you, not just through breathing and eating, but through quantum processes. This brings us to a profound realization. The atoms in your body right now are not the same atoms that were in your body 7 years ago. This is not just because you've eaten food and breathed air and drunk water. It's because your body is in a constant state of molecular turnover. Cells die and are replaced. Proteins are broken down and rebuilt. DNA is repaired and replicated. The average age of atoms in an adult human body is between 7 and 10 years, depending on the tissue. Your brain cells are an exception. Neurons in your cerebral cortex can last your entire lifetime. The atoms in those neurons are replaced, but the cells themselves persist. This means that the neurons firing right now, as you read these words, might be the same neurons that fired when you were a child, learning to read for the first time. But even those neurons have replaced their atoms. The carbon, nitrogen, oxygen, and phosphorus that make up the DNA in those neurons. Those atoms are different from the atoms that were there a decade ago. So here's the question. If all your atoms are replaced every 7 to 10 years, are you still the same person? What makes you _12_ if the physical matter that constitutes your body is constantly changing? The answer is that you are not a thing. You are a process. You are a pattern of organization imposed on matter that is flowing through you. You are like a whirlpool in a river. The water molecules in the whirlpool are constantly changing, but the whirlpool itself persists as a stable pattern. This is true not just for you, but for everything. A tree is not a fixed object. It's a process of matter flowing from the soil and air into wood and leaves, then back into the environment. A mountain is not permanent. It's a temporary accumulation of rock, slowly eroding, constantly changing. Even stars are processes, not things. They're patterns of matter and energy, fusing elements, radiating light, evolving over billions of years. The universe itself is a process. It's not a static collection of objects. It's a dynamic flow of matter and energy, constantly transforming, constantly evolving. And you are part of that flow. You are a temporary eddy in the cosmic river, a brief pattern in the eternal dance of atoms. But let's bring this back to something concrete. Let's talk about a specific element that reveals the deep strangeness of your cosmic origins. Gold. You have gold in your body. Not much, about 0.2 milligrams in the average adult human. That's roughly 10 trillion atoms of gold, scattered throughout your tissues. Gold doesn't play a biological role. Your body doesn't need it. But it's there, absorbed from food and water, incorporated into your cells. Where did that gold come from? Not from ordinary supernovae. For decades, scientists thought that all elements heavier than iron were created in supernova explosions. But the numbers didn't add up. Supernovae don't produce enough gold to account for the amount we observe in the universe. Something else had to be creating it. In 2017, scientists finally witnessed that something else. On August 17th, 2 neutron stars, the collapsed cores of dead massive stars, spiraled into each other and merged. The collision occurred 130 million light-years away in a galaxy called NGC 4993. The event released more energy in 1 second than the Sun will emit in its entire 10 billion-year lifetime, and it created something extraordinary. A kilonova. When neutron stars merge, the conditions become even more extreme than in a supernova. The density is so high, the temperature so intense, that neutrons are forced together, building up the heaviest elements in the periodic table. Gold, platinum, uranium. In the span of a few seconds, that collision created more gold than exists in the entire inner solar system. The explosion scattered that gold into space, enriching the interstellar medium. The gold in your body came from an event like that. Somewhere in the Milky Way galaxy, billions of years ago, 2 neutron stars collided. The gold they created drifted through space, became part of the molecular cloud that formed our solar system, ended up in Earth, entered the biosphere, and eventually made its way into you. Every gold atom in your body is the product of one of the most violent events in the universe. But here's what makes this truly mind-bending. Those neutron stars that collided, they were themselves the remnants of massive stars that had exploded as supernovae. Those supernovae scattered iron and other elements into space. Some of that material became part of new stars. Some of those stars exploded. Some of those explosions left behind neutron stars. And billions of years later, some of those neutron stars collided, creating gold. This means that the gold in your body is the product of a multi-generational stellar process. It required at least 2 supernovae to create the neutron stars, then a collision between those neutron stars to create the gold. The atoms in your body are not just ancient, they're the product of multiple cosmic catastrophes, each building on the previous one, each adding new layers of complexity to the universe. And gold is just one example. Every element in your body has a story like this. Iodine, essential for your thyroid function, was created in supernovae and kilonovae. Molybdenum, a trace element necessary for certain enzymes, came from the same sources. Even the calcium in your bones has a complex origin story, some from supernovae, some from white dwarf explosions called Type 1a supernovae, each contributing different isotopes. Your body is a museum of cosmic violence. Every element heavier than helium is the product of stellar death. You are made of catastrophe. You are built from the ashes of exploded stars, the debris of colliding neutron stars, the remnants of cosmic disasters that occurred billions of years before Earth existed. But let's shift perspective. Let's talk about what you're made of in terms of sheer numbers. Your body contains approximately 7 octillion atoms. That's 7 times 10 to the 27th power. To put that in perspective, there are more atoms in your body than there are stars in the observable universe. The observable universe contains roughly 200 billion trillion stars, 2 times 10 to the 23. Your body contains 10,000 times more atoms than there are stars in the cosmos. Now, here's where it gets strange. Because atoms are so small and so numerous, and because they've been cycling through the biosphere for billions of years, the probability that you share atoms with historical figures is essentially 100%. Right now, your body contains atoms that were once part of Julius Caesar, part of Cleopatra, part of Leonardo da Vinci, part of every human who has ever lived. The math is straightforward. When you breathe out, you exhale roughly 25 sextillion molecules with each breath. Those molecules disperse into the atmosphere. Within a few years, they've mixed throughout Earth's atmosphere. When other people breathe, they inhale some of those molecules. Given the number of molecules involved and the time that's passed, it's statistically certain that every breath you take contains molecules that were once in the lungs of historical figures. But it goes further than that. The atoms in your body have been part of countless organisms throughout Earth's history. Some of the carbon atoms in your cells were once part of dinosaurs. Some were part of the first trees that colonized land 400 million years ago. Some were part of the first photosynthetic bacteria 3 billion years ago. You are made of recycled life. Every atom in your body has been alive before, many times, in many different forms. This means that the boundary between life and non-life is not as clear as it seems. The atoms in your body are not, quote, 13. They're just atoms, following the laws of physics and chemistry. What makes you alive is not the atoms themselves, but the way they're organized. Life is a pattern, a process, a particular arrangement of matter that can maintain itself, reproduce, and evolve. When you die, the atoms don't die. They simply reorganize into different patterns. In a very real sense, death is an illusion. The matter that makes you up cannot be destroyed. It can only be transformed. When you die, your atoms will return to the environment. They'll become part of the soil, the air, the water. They'll be taken up by plants, eaten by animals, incorporated into new life. The pattern called you will dissolve, but the matter will continue. In that sense, you are immortal. But let's talk about the present moment. Right now, As you read these words, your body is performing an extraordinary feat of chemistry. Your cells are breaking down glucose molecules to produce ATP, the energy currency of life. This process, called cellular respiration, is essentially controlled combustion. You are burning fuel, just like a fire, but doing it in a controlled way that captures the energy in usable form. Every second, your body produces and consumes roughly 10 to the 21st molecules of ATP. That's a billion trillion molecules per second. Each ATP molecule contains carbon, hydrogen, nitrogen, oxygen, and phosphorus, all elements created in stars. The energy stored in the chemical bonds of ATP originally came from the sun, captured by plants through photosynthesis, transferred to you through food. But the sun's energy originally came from nuclear fusion, the same process that creates elements in stellar cores. So when you move your hand, when you think a thought, when your heart beats, you're using energy that originated in the sun's core, captured by plants, transferred to you, and released through the breaking of chemical bonds between atoms that were created in dying stars billions of years ago. You are powered by starlight, mediated through the chemistry of stellar debris. And here's something that will make you reconsider the nature of time. The light from the sun takes 8 minutes to reach Earth. That means when you see the sun, you're seeing it as it was 8 minutes ago. But the energy in that light, the photons hitting your skin, warming your body, those photons were created in the sun's core through fusion reactions. And because the sun's core is so dense, those photons take thousands of years to random walk their way from the core to the surface. The sunlight hitting your face right now was created tens of thousands of years ago. But it goes deeper. The fusion reactions in the sun's core are converting hydrogen into helium, releasing energy in the process. That hydrogen has been in the sun for 4.6 billion years since the solar system formed. But the hydrogen atoms themselves are 13.8 billion years old, created in the Big Bang. So when you feel the warmth of sunlight on your skin, you're feeling energy released by the fusion of atoms that are as old as the universe itself. Time is not what it seems. The past is not gone. It's present in every atom of your body. The Big Bang is not a distant event that happened long ago. It's happening now, in the hydrogen atoms in your cells. The supernovae that created the heavy elements in your body are not ancient history. They're present in the isotopic signatures of those elements. The entire history of the universe is encoded in the matter that makes you up. This is what physicists mean when they say that time is an illusion. Not that time doesn't exist, but that the distinction between past, present, and future is not as fundamental as it seems. At the deepest level, the universe is a four-dimensional structure, 3 dimensions of space and 1 of time, and all moments exist simultaneously. You experience time as flowing because of the way your consciousness processes information, but the atoms in your body exist across all of time. They have a past, a present, and a future, all equally real. Let's zoom out one more time. Let's consider your place in the cosmic timeline. The universe is 13.8 billion years old. Earth is 4.5 billion years old. Life on Earth began roughly 3.8 billion years ago. Humans evolved around 300,000 years ago. You've been alive for a few decades. In the grand scheme of cosmic history, your lifetime is vanishingly brief. If we compress the entire history of the universe into a single year, with the Big Bang occurring at midnight on January 1st, Earth forms in early September. Life begins in mid-September. Dinosaurs appear on December 25th. They go extinct on December 30th. Humans appear in the last hour of December 31st. Your entire lifetime is a fraction of a second before midnight. But here's the paradox. Despite the brevity of your existence, you are the most complex structure the universe has ever created. Your brain contains 86 billion neurons, each connected to thousands of other neurons, forming trillions of synapses. The number of possible states your brain can be in exceeds the number of atoms in the observable universe. You are more complex than galaxies, more intricate than nebulae, more sophisticated than any star. and you are conscious. You have subjective experiences. You feel emotions. You have thoughts. You wonder about your place in the universe. This is extraordinary. For 13.8 billion years, matter has been evolving, increasing in complexity. From quarks to protons to atoms to molecules to cells to organisms to brains. And now, in you, matter has become aware of itself. The universe has developed the capacity to contemplate its own existence. This is not a common occurrence. As far as we know, consciousness is rare in the universe. It requires very specific conditions: a stable star, a rocky planet in the habitable zone, liquid water, organic chemistry, billions of years of evolution. Most of the universe is empty space. Most planets are lifeless. Most stars will never be orbited by a world where matter becomes conscious. You are a cosmic rarity. You are one of the universe's experiments in self-awareness. And that makes you precious. Not in a sentimental way, but in a literal, objective sense. You are a structure of extraordinary complexity and improbability. You are a temporary island of order in a universe trending toward entropy. You are matter that has organized itself to the point where it can understand its own origins, contemplate its own nature, and wonder about its place in the cosmos. But you are also fragile. The pattern that makes you you is maintained by constant energy input. You must eat, breathe, maintain your body temperature. If any of these processes stop, the pattern dissolves. The atoms remain, but the organization is lost. Consciousness ceases. The universe's experiment in self-awareness, in your particular form, comes to an end. This is the tragedy and the beauty of existence. You are a temporary phenomenon. You will not last forever. But while you exist, you have the capacity to experience wonder, to feel joy, to contemplate the infinite. You are the universe's way of knowing itself, and that knowledge is precious precisely because it is temporary. So what does all this mean? What should you do with the knowledge that you are made of atoms created in dying stars, that your body is a temporary pattern in the flow of cosmic matter, that you are the universe experiencing itself? Perhaps it means you should pay attention, really pay attention, to the feeling of your breath, to the sensation of sunlight on your skin, to the taste of food, to the sound of music, to the face of someone you love. Because all of these experiences are the universe experiencing itself through you. When you feel joy, the universe feels joy. When you experience beauty, the universe experiences beauty. You are not separate from the cosmos. You are its eyes, its ears, its consciousness. Perhaps it means you should feel connected to other people who are made of the same stellar debris as you, to other living things who share your atomic heritage, to the Earth, which is your home and the source of the atoms that make you up, to the stars, which created those atoms. You are not alone. You are part of an unbroken chain of existence stretching back to the beginning of time. Perhaps it means you should feel humble. You are not the center of the universe. You are not the purpose of creation. You are a tiny, temporary pattern in an incomprehensibly vast cosmos. But that doesn't diminish your value. It enhances it. Because despite your smallness, despite your brevity, you have the capacity to understand the universe that created you. You can contemplate infinity. You can grasp the deep connections between yourself and the stars. You are small, but you are also magnificent. And perhaps it means you should feel grateful. Grateful for the improbable sequence of events that led to your existence. Grateful for the stars that died to create the atoms in your body. Grateful for the billions of years of cosmic and biological evolution that produced a being capable of consciousness. Grateful for this moment, right now, when you have the opportunity to experience the wonder of existence. Because in the end, that's what you are. You are wonder made flesh. You are stardust that has learned to contemplate the stars. You are the universe's way of knowing itself. And for this brief moment in cosmic history, you have the extraordinary privilege of being alive, of being conscious, of being aware of your own cosmic origins. That is not a small thing. That is everything. Now we need to confront something uncomfortable. Something that might make you skeptical of everything you've just heard. Because I know what you're thinking. This all sounds beautiful, poetic, almost too perfect. We're made of stardust. We're the universe experiencing itself. Every atom has a cosmic journey. It's the kind of thing that gets shared on social media with pictures of galaxies and inspirational quotes. And that's exactly the problem. So let me be completely honest with you. There's a lot of pseudoscience out there that uses these same ideas. Cosmic connection, quantum consciousness, we're all one with the universe, to sell you crystals, meditation apps, or some new age philosophy that has nothing to do with actual physics. And I understand if that makes you suspicious. It should. Skepticism is healthy. It's essential. It's what separates science from wishful thinking. But here's the crucial difference. Everything I've told you is not metaphor. It's not poetry. It's not spiritual philosophy dressed up in scientific language. It's measurable, testable, physical reality. And I can prove it. Let's start with the most fundamental claim, that hydrogen in your body is 13.8 billion years old, created in the Big Bang. How do we know this? Not from speculation, not from philosophical reasoning, from precision measurements of the cosmic microwave background radiation. In 2009, the Planck satellite mapped the afterglow of the Big Bang with unprecedented accuracy. By analyzing the tiny temperature fluctuations in this radiation, scientists determined that the universe is 13.796 billion years old, give or take 23 million years. That's a precision of better than 1%. But more importantly, the cosmic microwave background tells us about the conditions in the early universe: the temperature, the density, the rate of expansion. And from those conditions, we can calculate exactly how much hydrogen and helium formed in the first 3 minutes. The prediction from Big Bang nucleosynthesis theory is that the universe should be roughly 75% hydrogen and 25% helium by mass, with trace amounts of lithium. When astronomers measure the composition of the oldest stars, stars that formed from nearly pristine Big Bang material, they find exactly those ratios. The theory works. The hydrogen in your body really is primordial. Now let's address the claim about stellar nucleosynthesis, that heavier elements were created in stars. This isn't speculation either. We can watch it happening. When astronomers observe supernova remnants like the Crab Nebula, they can measure the spectrum of light coming from the expanding gas. That spectrum shows emission lines from specific elements: oxygen, carbon, silicon, iron. We're literally seeing the products of stellar nucleosynthesis scattered through space. We can measure the isotopic ratios. We can compare them to theoretical predictions from stellar evolution models. They match. In 2014, astronomers using the Atacama Large Millimeter Array detected molecules of aluminum oxide in the gas surrounding a red supergiant star called VY Canis Majoris. Aluminum is created through stellar nucleosynthesis. They were watching it being manufactured in real time, in a star that will explode as a supernova within the next 100,000 years. This isn't ancient history. This is ongoing. Stars are creating heavy elements right now, at this very moment, throughout the universe. And the kilonova I mentioned, the collision of two neutron stars that creates gold and other heavy elements, we didn't just theorize about that. We observed it. On August 17, 2017, the LIGO and Virgo gravitational wave detectors picked up the signal of two neutron stars spiraling into each other. Within 2 seconds, telescopes around the world turned to look at the source. They saw the explosion. They measured its spectrum. And in that spectrum, they found the unmistakable signatures of heavy elements being created: gold, platinum, uranium. The theoretical prediction was that such collisions should produce about 10 times the mass of Earth in pure gold. The observations confirmed it. This is not speculation. This is not metaphor. This is direct observational evidence. We have watched the universe create the elements that make up your body. But let's go further. Let's address the claim that atoms in your body have cycled through countless organisms. How do we know this? Through isotope tracing. Scientists can measure the ratio of carbon-14 to carbon-12 in organic material. Carbon-14 is radioactive, with a half-life of 5,730 years. It's constantly being created in the atmosphere by cosmic rays hitting nitrogen atoms. Plants absorb this carbon-14 through photosynthesis. Animals eat the plants. The carbon-14 becomes part of their tissues. When the organism dies, it stops taking in new carbon, and the carbon-14 begins to decay. By measuring how much is left, we can determine when the organism died. This technique, called radiocarbon dating, has been used to date tens of thousands of archaeological samples. It works. It's been cross-checked against tree rings, ice cores, and other independent dating methods. The agreement is remarkable. And what it tells us is that carbon atoms really do cycle through the biosphere. The carbon in your body was recently part of other organisms. Before that, other organisms. Before that, the atmosphere. Before that, other organisms. The cycle goes back billions of years. We can even trace specific atoms through the food chain. Scientists use stable isotope analysis to track the movement of nitrogen, carbon, and other elements from soil to plants to animals to humans. They can determine what ancient peoples ate by analyzing the isotopic composition of their bones. They can track the migration patterns of animals by analyzing the isotopic signatures in their teeth, which reflect the water they drank in different locations. This is not theoretical. This is forensic science. We can literally trace the history of individual atoms. Now, I know what some of you are thinking. Quote 16. And you're right to push back on that. Science can tell us what we're made of. It can tell us how we got here. But it can't tell us what it means. Meaning is something we construct. It's subjective. It's personal. And that's okay. That's not a weakness. That's what makes us human. But here's what science can tell us, objectively, without interpretation. You are a physical system of extraordinary complexity. Your brain contains 86 billion neurons. Each neuron can form thousands of synaptic connections. The total number of synapses in your brain is roughly 100 trillion. That's more connections than there are stars in 1,000 Milky Way galaxies. And those connections are not random. They're organized into networks that process information, store memories, generate predictions, and produce the subjective experience of consciousness. We don't fully understand how consciousness emerges from neural activity. That's one of the great unsolved problems in science. But we know it does. We know that specific patterns of neural firing correlate with specific conscious experiences. We know that damage to certain brain regions eliminates certain aspects of consciousness. We know that anesthetics, which disrupt neural communication, eliminate consciousness entirely. Consciousness is not separate from the physical brain. It's a product of it. It's what happens when matter organizes itself in a sufficiently complex way. And that matter, the atoms in your neurons, the molecules in your synapses, really did come from stars. That's not metaphor. That's physics. The carbon in your neurotransmitters was forged in a red giant. The calcium ions triggering your action potentials were created in a supernova. The iron in your hemoglobin, carrying oxygen to your brain cells, was synthesized in the final seconds of a massive star's life. These are facts, measurable, verifiable, true. So when I say you are the universe experiencing itself, I'm not making a mystical claim. I'm making a physical one. You are a structure made of atoms that were created in stellar furnaces. Those atoms have organized themselves, through billions of years of cosmic and biological evolution, into a configuration that can process information and generate conscious experience. The universe, through you, has developed the capacity to observe itself, to understand itself, to contemplate its own existence. That's not poetry. That's an accurate description of physical reality. But let's address the elephant in the room, the thing that makes people most skeptical about these ideas. The claim that we're all connected, that we're all made of the same cosmic material, that the boundaries between self and other are illusions. This sounds like the kind of thing that gets used to justify all sorts of fuzzy thinking. We're all one, man. We're all connected to the cosmic consciousness. And yes, That kind of language is often used to sell nonsense. But strip away the mysticism, and there's a hard physical truth underneath. You really are exchanging atoms with the environment constantly. Every breath you take contains roughly 10 to the 22nd molecules. You exhale roughly the same number. Those molecules disperse into the atmosphere. Within a year, they've mixed throughout the global atmosphere. Within a few years, some of them have been breathed by other people. The math is straightforward. Given the number of molecules involved and the time that's passed since historical figures lived, it's statistically certain that you have atoms in your body that were once part of Julius Caesar, Cleopatra, Leonardo da Vinci, and every other human who lived more than a few centuries ago. This isn't mysticism, it's statistics. It's the same kind of calculation that allows us to predict the behavior of gases, the spread of pollutants, the mixing of ocean currents. The atmosphere is a well-mixed reservoir. Molecules don't stay in one place, they spread out. And given enough time, they spread everywhere. The same is true for the atoms in your body. The calcium in your bones will eventually return to the environment. It will be taken up by plants. It will be eaten by animals. It will become part of other humans. Billions of years from now, some of those calcium atoms might be part of organisms on other planets, if life spreads beyond Earth. The atoms are not yours. They're borrowed. They're temporary. They're part of a cosmic cycle that's been ongoing for billions of years and will continue for billions more. This is not a spiritual claim. It's a physical one. Matter is conserved. Atoms are recycled. The boundaries between organisms are permeable. You are not a closed system. You are an open system, constantly exchanging matter and energy with the environment. The distinction between, quote, 18 and, quote, 19 is a useful fiction, a conceptual boundary that helps you navigate the world, but it's not a fundamental feature of reality. Now, let's talk about the limits of our knowledge, because it's important to be honest about what we don't know. We don't know how consciousness arises from neural activity. We have correlations. We can see which brain regions are active during specific conscious experiences. But we don't have a complete theory of how subjective experience emerges from objective physical processes. This is called the, quote, 20, and it's genuinely hard. It might be the hardest problem in science. We also don't know if consciousness is unique to biological systems. Could a sufficiently complex computer become conscious? Could consciousness exist in forms we don't recognize? We don't know. We have theories, but no definitive answers. We don't know if life exists elsewhere in the universe. We know the ingredients for life are common: carbon, hydrogen, nitrogen, oxygen, water. We know planets are common. We know organic molecules form naturally in space. But we don't know if the step from chemistry to biology is easy or hard. We don't know if life is abundant or rare. We're looking. We're searching. But so far, we've found no definitive evidence of life beyond Earth. We don't know the ultimate fate of the universe. Current observations suggest the universe will continue expanding forever, eventually reaching a state of maximum entropy called heat death, where no energy is available to do work, where stars have all burned out, where black holes have evaporated, where nothing happens anymore. But this is based on our current understanding of dark energy, and dark energy is still mysterious. We don't know what it is or how it behaves. The future is uncertain. And we don't know if our universe is the only one. Some theories in physics suggest the existence of a multiverse, countless other universes with different physical laws, different constants of nature, different histories. If the multiverse exists, then our universe, with its specific properties that allow for stars, planets, and life, might be just one possibility among infinite others. But we have no way to test this. The multiverse, if it exists, might be forever beyond our ability to observe. These are real limitations, real gaps in our knowledge, and it's important to acknowledge them. Science is not about claiming to have all the answers. It's about honestly assessing what we know, what we don't know, and what we can potentially find out. But here's what we do know with extraordinary confidence. The universe is 13.8 billion years old. It began in a hot, dense state and has been expanding and cooling ever since. The first atoms formed in the first 3 minutes. The first stars formed a few 100 million years later. Those stars created heavy elements through nuclear fusion. When they died, they scattered those elements into space. New generations of stars formed from that enriched material. Our Sun is one of those later generation stars. Earth formed from the debris of earlier stellar generations. Life emerged on Earth roughly 3.8 billion years ago. That life evolved, increasing in complexity, eventually producing organisms with nervous systems, brains, and consciousness. You are one of those organisms. You are made of atoms that were created in stars. Those atoms have been recycled through countless organisms before you. They will be recycled through countless organisms after you. This is not speculation. This is not interpretation. This is the scientific consensus, supported by overwhelming evidence from multiple independent lines of inquiry. Cosmology, stellar astrophysics, nuclear physics, geology, paleontology, biology, chemistry. All of these fields converge on the same story. The details might change as we learn more. The precision might improve, but the basic narrative is solid. You are made of stardust. That's not a metaphor, that's a fact. Now, let's push this even further. Let's talk about the most extreme implications of what we know. Because if you really take this seriously, if you really internalize the fact that you are a temporary pattern of atoms that have been on a 13.8 billion year journey, it changes everything. It changes how you see death. Death is not an ending, it's a transformation. The pattern called _quote_22_ dissolves, but the atoms continue. They return to the environment. They become part of new patterns. In a very real sense, you cannot die. The matter that makes you up is eternal. Only the specific arrangement is temporary. It changes how you see other people. They are not separate from you. They are made of the same cosmic material. The atoms in their bodies have the same ancient origins as the atoms in yours. The boundaries between you and them are arbitrary, permeable, temporary. You are all temporary expressions of the same underlying reality. It changes how you see the Earth. The planet is not just your home, it's your source. Every atom in your body came from Earth, from the air, the water, the soil, the food chain. You are not on Earth, you are of Earth. You are a part of it, temporarily organized in a way that can walk around and think and wonder. It changes how you see the stars. They are not distant, irrelevant objects. They are your ancestors. They created the atoms that make you up. When you look at the night sky, you are looking at the furnaces that forged your body. You are looking at your own deep history. And it changes how you see this moment, right now, this present instant. Because this moment is all you have. The past is gone. It exists only as memory, as information encoded in your brain. The future hasn't happened yet. It exists only as prediction, as models your brain constructs. The only thing that's real is now. This moment, this breath, this heartbeat, this thought. And in this moment, you are the universe experiencing itself. You are matter that has become conscious. You are atoms that were forged in stellar furnaces, scattered by supernovae, assembled into planets, organized into life, evolved into complexity, and now, right now, aware of their own existence. This is extraordinary. This is miraculous. Not in a supernatural sense, but in the sense of being worthy of wonder, of awe, of deep appreciation. You are not a mistake. You are not an accident. You are the inevitable result of the laws of physics playing out over billions of years. The universe, through you, has developed eyes to see itself, ears to hear itself, a mind to understand itself. You are the universe's way of knowing that it exists, and that knowledge is precious. Because as far as we know, consciousness is rare. Most of the universe is empty space. Most planets are lifeless. Most stars will never be orbited by a world where matter becomes aware. You are one of the exceptions. You are one of the places where the universe has become conscious. And that makes you valuable. Not in a sentimental way, but in an objective, physical sense. You are a rare and complex structure in a universe that tends towards simplicity and disorder. But you are also fragile. The pattern that makes you _quote_23_ requires constant maintenance. You must eat, you must breathe, you must maintain your body temperature. If any of these processes stop, the pattern dissolves. Consciousness ceases. The universe's experiment in self-awareness, in your particular form, comes to an end. This is the paradox of existence. You are both eternal and temporary. The atoms that make you up will exist forever. But the specific arrangement of those atoms that creates your consciousness will last only a few decades. You are simultaneously ancient and fleeting, cosmic and fragile, infinite and finite. So what do you do with this knowledge? How do you live, knowing that you are a temporary pattern of ancient atoms, a brief moment of consciousness in an eternal universe? Perhaps you pay attention, really pay attention, to the sensation of breathing, to the feeling of your heartbeat, to the taste of food, to the warmth of sunlight, to the sound of music, to the face of someone you love. Because these experiences are not separate from the cosmos. They are the cosmos experiencing itself through you. Perhaps you feel gratitude for the improbable sequence of events that led to your existence, for the stars that died to create your atoms, for the billions of years of evolution that produced your consciousness, for this moment, right now, when you have the capacity to understand your own cosmic origins. Perhaps you feel humility. You are not the center of the universe. You are not the purpose of creation. You are a tiny, temporary pattern in an incomprehensibly vast cosmos. But that doesn't diminish your value. It enhances it. Because despite your smallness, you have the capacity to understand the universe that created you. And perhaps you feel connection to other people who are made of the same stellar debris, to other living things who share your atomic heritage, to the Earth, which is your source and your home, to the stars, which created the elements that make you up. You are not alone. You are part of an unbroken chain of existence stretching back to the beginning of time. This is not mysticism. This is not wishful thinking. This is physical reality, understood through science, experienced through consciousness. You are made of stardust. You are the universe experiencing itself. You are a temporary pattern in the eternal flow of matter and energy. And for this brief moment, you have the extraordinary privilege of being aware of it. That awareness is everything. It's what makes you human. It's what makes you precious. It's what makes this moment, right now, as you read these words, as your heart beats, as your neurons fire, as ancient atoms flow through your body, worth experiencing fully, deeply, with wonder and gratitude and awe. Because you are not just in the universe, you are the universe. And the universe, through you, is finally awake. But now we need to go deeper, beyond the science, beyond the measurements, beyond even the wonder of knowing your atomic origins. Because there's a question we haven't fully confronted yet. A question that sits at the intersection of physics and philosophy, of knowledge and mystery. A question that might be more important than any answer we could give. If you are made of atoms that are 13.8 billion years old, if those atoms have cycled through stars and planets and countless organisms, if the matter that makes you up is eternal and will continue long after you're gone, then what, exactly, are you? This is not a rhetorical question. It's the deepest question you can ask. Because the answer is not obvious. You feel like a unified self, a single consciousness experiencing the world from a particular point of view. You have memories that seem to belong to you. You have thoughts that feel like they're yours. You have a sense of identity that persists through time. You are you. That seems self-evident. But we've just established that the atoms in your body are not permanent. They're replaced every 7 to 10 years. The matter that made up your body when you were 7 years old is not the same matter that makes up your body now. So if you are not your atoms, what are you? Are you the pattern? The organization? The information encoded in the structure of your brain? Philosophers have wrestled with this question for millennia. It's called the problem of personal identity. The ancient Greeks had a thought experiment, the ship of Theseus. Imagine a ship where, over time, every plank of wood is replaced. Eventually, none of the original material remains. Is it still the same ship? And if you take all the old planks and build a second ship, which one is the real ship of Theseus? You are the ship of Theseus. Your atoms are the planks. They're constantly being replaced. And yet, you persist. You feel like the same person you were 10 years ago, even though almost none of the atoms in your body are the same. So what is it that persists? What is the quote 24 that continues through time? Modern neuroscience suggests that you are not a thing at all. You are a process. You are a pattern of neural activity, constantly changing, constantly updating, constantly reconstructing itself. Your sense of being a unified self is an illusion, a useful fiction created by your brain to help you navigate the world. In reality, you are a collection of parallel processes, competing and cooperating, generating the experience of consciousness moment by moment. This is not speculation. Brain imaging studies show that there is no single quote 25 in the brain. There is no central command center where quote 26 live. Instead, consciousness emerges from the coordinated activity of billions of neurons distributed throughout the brain. Damage to different regions produces different deficits. Damage to the hippocampus impairs memory formation. Damage to the prefrontal cortex affects decision-making and personality. Damage to the visual cortex eliminates visual experience. There is no single place where, quote, 27, quote, reside. You are distributed. You are emergent. You are a process, not a thing. And that process is made of atoms that came from stars. The neurons firing in your brain right now, the ones generating your thoughts, your sense of self, your experience of reading these words. Those neurons are made of carbon from red giants, oxygen from supernovae, nitrogen from massive stars. Your consciousness is not separate from the physical universe. It is the physical universe, organized in a particular way. But here's where it gets truly strange. Because if consciousness is a physical process, if it emerges from the organization of matter, then consciousness is not unique to biological systems. In principle, any sufficiently complex system that processes information in the right way could be conscious. A computer, perhaps, an artificial intelligence, maybe even systems we don't recognize as conscious at all. This raises a profound question. Is the universe itself conscious? Not in the sense of having a mind or intentions or personality, but in the sense of being a vast information processing system, with consciousness emerging at different scales and in different forms. You are conscious. Other humans are conscious. Animals are conscious to varying degrees. But what about ecosystems? What about the biosphere as a whole? What about the planet? What about the galaxy? What about the universe itself? We don't know. We can't know because we don't have a complete theory of consciousness. We don't know what the necessary and sufficient conditions are for consciousness to emerge. We don't know if consciousness is binary, either present or absent, or if it exists on a spectrum. We don't know if consciousness requires biology, or if it's a more general property of complex information processing systems. But here's what we do know. The universe has organized itself, through you, into a structure capable of understanding its own origins. The atoms created in the Big Bang and in stellar furnaces have arranged themselves into patterns that can contemplate the Big Bang and stellar nucleosynthesis. Matter has become aware of matter. The universe has developed the capacity to observe itself. This is extraordinary. This is unprecedented. As far as we know, for the first 13 billion years of cosmic history, the universe existed without being aware of its own existence. Stars formed and died. Galaxies collided. Planets orbited their suns. But none of it was observed. None of it was understood. None of it was contemplated. The universe was unconscious. And then, on at least one planet orbiting an ordinary star in an ordinary galaxy, something changed. Matter organized itself into life. Life evolved. Nervous systems developed. brains became more complex. And eventually, roughly 300,000 years ago, a species emerged that could ask questions about its own origins. Humans. Us. You. For the first time in cosmic history, the universe could look at itself and ask, where did I come from? What am I made of? Why do I exist? These questions are not separate from the universe. They are the universe asking questions about itself. You are not an observer standing outside reality looking in. You are reality, observing itself from the inside. But let's be honest about what we don't know, because the gaps in our knowledge are as important as the knowledge itself. We don't know why the universe exists. We don't know why the laws of physics are what they are. We don't know why the fundamental constants have the values they do. We don't know if our universe is the only one, or if it's part of a vast multiverse. We don't know if the universe had a beginning, or if it's part of an eternal cycle of expansion and contraction. We don't know if time is fundamental, or if it's an emergent property of something deeper. We don't know what dark matter is. It makes up 85% of the matter in the universe, but we've never directly detected it. We know it exists because of its gravitational effects, but we don't know what it's made of. We don't know what dark energy is. It makes up 68% of the universe's total energy, and it's causing the expansion of the universe to accelerate, but we have no idea what it is or why it exists. We don't know if the universe will exist forever, or if it will eventually end. Current observations suggest the universe will continue expanding forever, eventually reaching a state of maximum entropy where no energy is available to do work, where stars have all burned out, where black holes have evaporated, where nothing happens anymore. But this is based on our current understanding, and our understanding is incomplete. We don't know if consciousness can exist without biology. We don't know if artificial intelligence can become truly conscious. We don't know if consciousness is unique to Earth, or if it exists elsewhere in the universe. We're looking, we're searching, but so far, we've found no definitive evidence of life beyond our planet. We don't know how life began. We know it happened roughly 3.8 billion years ago. We know the basic chemistry involved, but we don't know the exact sequence of events that led from non-living chemistry to living cells. We have theories, we have experiments, but we don't have a complete answer. We don't know why the universe is comprehensible. Why do the laws of physics exist? Why are they mathematical? Why can we understand them? The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics in the natural sciences. The universe doesn't have to be understandable. It doesn't have to follow mathematical laws, but it does. And we don't know why. These are not small gaps. These are fundamental mysteries, and it's important to acknowledge them. Because the honest answer to many of the deepest questions is, we don't know. And that's okay. That's not a failure of science. That's the nature of reality. The universe is under no obligation to make sense to us. The fact that we can understand as much as we do is already extraordinary. But here's what makes these mysteries beautiful rather than frustrating. They mean there's more to discover. They mean the story is not finished. They mean that future generations will know things we can't even imagine. Just as we know things that would have seemed like magic to people 1,000 years ago, people 1,000 years from now will know things that would seem like magic to us. The atoms in your body will be part of that future. Long after you're gone, long after your consciousness has ceased, the matter that makes you up will continue. It will be part of other organisms, other processes, other discoveries. The carbon in your neurons might one day be part of a brain that understands consciousness. The iron in your blood might one day be part of a telescope that discovers life on another planet. The hydrogen in your cells might one day be part of a fusion reactor that powers a civilization spreading through the galaxy. You are not the end of the story. You are a chapter, a brief moment in the eternal flow of matter through time. But you are a conscious chapter. You are the part of the story that can read itself, and that makes you precious. Now, let me take you back to where we started. Remember the first words of this journey? Right now, as you read these words, your body contains atoms that are 13.8 billion years old. We've traveled through the entire history of the universe to understand what that means. We've traced atoms from the Big Bang, through stellar furnaces, through supernovae, through the formation of Earth, through the evolution of life, to this present moment. We've confronted the science, the skepticism, the mysteries, the implications. And now, here you are, still reading, still breathing, still thinking. The atoms in your body are still 13.8 billion years old. That hasn't changed. But perhaps your understanding of what that means has changed. Perhaps you see yourself differently now. Not as a separate individual, but as a temporary pattern in the cosmic flow. Not as a fixed thing, but as a process. Not as separate from the universe, but as the universe experiencing itself. Hold up your hand again. Look at it. 7 octillion atoms. Each one with a history spanning billions of years. Each one created in a star. Each one part of countless organisms before you. Each one destined to continue long after you're gone. Your hand is not just a hand. It's a museum of cosmic history. It's a temporary assembly of ancient matter. It's the universe, organized in a way that can grasp things, touch things, create things. And your brain, the organ generating your thoughts right now, is even more extraordinary. 86 billion neurons, 100 trillion synapses, more connections than stars in 1,000 galaxies. All of it made from stellar debris, all of it processing information, all of it generating the experience of consciousness. Your brain is the most complex structure we know of in the universe, and it's made of stardust. But here's the final truth, the one that ties everything together. You are not just made of stardust. You are stardust that has learned to wonder about stardust. You are atoms that have organized themselves to contemplate atoms. You are the universe that has become aware of the universe. And in this moment, right now, as you read these words, as your heart beats, as your neurons fire, as ancient atoms flow through your body, you are experiencing something that might be the rarest phenomenon in the cosmos: consciousness. We don't know how common consciousness is in the universe. We don't know if we're alone or if the cosmos is teeming with other minds. But we know that consciousness is not common in our immediate neighborhood. Earth is the only place we know of where matter has become aware. You are one of roughly 8 billion humans on this planet, and humans are one species among millions, and Earth is one planet among trillions. The probability of your existence is vanishingly small, and yet, here you are. So what do you do with this knowledge? What do you do with the understanding that you are a temporary pattern of ancient atoms, a brief moment of consciousness in an eternal universe? A rare and precious structure in a cosmos that tends towards simplicity and disorder. Perhaps you simply pay attention. Perhaps you notice the miracle of each breath, each heartbeat, each moment of awareness. Perhaps you recognize that every experience you have, every sensation, every thought, every emotion, is the universe experiencing itself through you. When you feel joy, the universe feels joy. When you experience beauty, the universe experiences beauty. When you contemplate infinity, the universe contemplates infinity. Perhaps you feel connected, not in a mystical sense, but in a physical one. You are made of the same atoms as the stars. You are part of the same cosmic process as galaxies and nebulae and black holes. The boundaries between you and the rest of the universe are permeable, temporary, arbitrary. You are not separate. You are continuous. You are part of the whole. Perhaps you feel humble. You are not the center of the universe. You are not the purpose of creation. You are a tiny, temporary pattern in an incomprehensibly vast cosmos. But that doesn't diminish your value, it enhances it. Because despite your smallness, despite your brevity, you have the capacity to understand the universe that created you. You can contemplate infinity. You can grasp the deep connections between yourself and the stars. You are small, but you are also magnificent. And perhaps you feel grateful. Grateful for the improbable sequence of events that led to your existence. Grateful for the stars that died to create your atoms. Grateful for the billions of years of cosmic and biological evolution that produced consciousness. Grateful for this moment, right now, when you have the extraordinary privilege of being aware, of being alive, of being part of the universe's ongoing experiment in self-understanding. Because in the end, that's what you are. You are an experiment. The universe is trying something. It's organizing matter in increasingly complex ways, seeing what emerges. For billions of years, it tried stars, then planets, then chemistry, then life, then nervous systems, then brains, then consciousness. And now, through you, it's trying something even more extraordinary: self-awareness. The universe is trying to understand itself, and you are part of that attempt. Every question you ask, every thought you have, every moment of wonder you experience, that's the universe exploring its own nature. You are not separate from that exploration. You are the exploration. You are the universe's way of knowing that it exists. So here's my final question for you. Not a question I can answer. A question only you can answer. A question that might be more important than any of the facts we've discussed. Now that you know you are made of atoms that are 13.8 billion years old, now that you know those atoms came from dying stars, now that you know you are a temporary pattern in the eternal flow of cosmic matter, now that you know you are the universe experiencing itself, what will you do with this moment? This brief, precious, improbable moment of consciousness? Will you pay attention? Will you notice the miracle of existence? Will you feel the connection between yourself and the cosmos? Will you experience the wonder of being alive, of being aware, of being part of something infinitely larger than yourself? Because this moment is all you have. The past is gone. The future hasn't arrived. The only thing that's real is now. This breath, this heartbeat, this thought. And in this moment, you are the universe, awake and aware, contemplating its own existence. That is not a small thing. That is everything. You are made of stardust. You are ancient and eternal. You are temporary and precious. You are the universe experiencing itself. And for this brief moment in cosmic history, you have the extraordinary privilege of knowing it. Don't waste it.